Okay, we're looking now at example 3 in lesson 7.3. This example is about writing fractions as percents. So they're giving us two fractions, 3/8 and 5/3, and asking us to write them as percents. Here's A, 3/8 somehow they're getting is equivalent to 375 thousandths, which then, using our method from before, going from a decimal to a percent, they're moving the decimal point to the right twice and adding a percent sign, so it's 37.5 or 37.5%. Now they're not showing us how they got that 3/8 into its decimal form. They are giving us a page number to look back at. I'm just going to demonstrate over on the side what one or two methods that they could have used to do that. 3/8 is a fraction, and a fraction is also a division. So I'm going to give myself a little more room and work down here. So 3/8 can also be interpreted as 3 divided by 8. Now be careful, it's not 8 divided by 3, it's 3 divided by 8. You can use long division to get the decimal form of that. So here I am writing 3 divided by 8. And then you can use either traditional or partial quotients to get the decimal. I'm going to go ahead and do traditional division. 8 doesn't fit into 3, so I'm going to add a decimal point and bring it up into the quotient, the answer, and I'm going to start adding zeros. 8 goes into 30. Let's see, 8 times 3 is 24. 3 times 8 is 24. I'm going to subtract and get a remainder of 6. I'm not quite done yet, so I'm going to bring down a 0 and add another at the 0. See, I can add as many zeros as I want to that 3 as long as there's a decimal point here. 3.00 is still 3. Let's see, 8 goes into 60. The closest I can get is 7 times 8, 56. My remainder now is 4. I've still got a remainder, so I'm going to keep going. I'm going to add one more 0, bring it down, and 8 goes into 40 exactly 5 times. 5 times 8 is 40, so I'm going to stop there. So you can use long division to get that decimal that they got in part A. All right, looking at example B. Let me get my screen shade back here. 5/3 is equivalent to the decimal 1 and 6 repeating forever. We'll talk about how to get that in just a minute. So they're writing it as a percent, moving the decimal point to the right twice, 166.6 repeating percent. I just want to demonstrate how you could use partial quotients to get the fraction into its decimal form. 5/3, of course, is equivalent to 5 divided by 3. And I can do 5 divided by 3. Now, since I want to get a decimal, and I want it to go to 2 decimal places because that's where percent is located, I'm going to start out by adding a decimal point and 2 zeros, and I'm going to do my partial products using 500 divided by 3. Before I do this, I'm going to take a look at my fraction. 5/3 is equivalent to 1 2/3. So that means when I'm all done over here, my decimal should be 1 point something. And I have to keep that in mind when I place my decimal point at the end. For now, I'm going to go ahead and kind of forget about the decimal point and think about how many times 3 would go into 500. Easy thing to do would be just to say, well, 100 times 3 is 300. And I'm going to subtract, and I'll get 200. Now I'm going to use my extended math facts, and I think, let's see, 3 times 60 would be 180. And that's going to give me a remainder of 20. 3 still goes into 20 6 times. 6 times 3 is 18, so I've got a remainder of 2. Now my remainder is less than my divisor, the 3, so I'm going to stop and write a mixed number. I got 166 and 2/3, which is approximately, if I round it to the nearest whole number, it's about 167. So there's the answer to 500 divided by 3. It's about 167. If I have to go back and think, well, I wanted a decimal, that's 1 point something, that places the decimal point right here, 1.67. So I'm getting almost exactly the same answer that they got, but I'm rounding it. It's approximately 1.67 as a decimal. Moving the decimal point to the right twice, it's almost 167%. So it's a little more rounded, but it's basically the same answer that they got, and it would be sufficient for anything, any expectations I would have of my 8th grade students. Let's take a look at the examples now in your note-taking guide. We're given 4/9, and we're being asked to write it as a percent. We're going to go first to its decimal form, and then we can find its percent form. I'm going to work down here. I'm going to try, well, 4/9 is 4 divided by 9. This time I'm going to use traditional division. I'm going to think 9 doesn't go into 4, so I'm going to add a decimal point and a 0. Bring my decimal point up into the quotient and start dividing. 9, let's see, goes into 40. 9 times 4 is 36, which is going to give me a remainder of 4. If I bring down another 0, I'm going to get 9 goes into 40 4 times again, remainder 36. And you can kind of see that this is going to keep going forever and ever. So we could say that 4/9 is equivalent to the decimal 0.444 and so on, right? Or we could say 0.4 repeating. Now thinking of it in percent form, I'm going to move my decimal point to the right twice. So it looks like I'm going to get 44.4 repeating percent. So almost 44.5%, or you could say it's a little over 44%. Looking at B, I'm given 7/4. This time I think I'm going to use my partial quotients method. You can use whichever method you like. First of all, I know 7/4 is going to be equivalent to 1 3/4. Wait a minute. Knowing that, here's another thing you can do sometimes. Since we're looking at fourths here, 4 is compatible with 100, isn't it? This would be a lot easier. I don't have to do long division in this case because 4 times 25 is 100. So I can just go 7 times 4, I'm sorry, not times 4, 7 times 25 and get my numerator here. And I know it takes 4 25s to make 100. So I'm going to have 100 plus 3 more 25s, 75. So this fraction, 7/4, is equivalent to 175 over 100, which as a decimal is 175 hundredths is 1.75. And as a percent, it's 175%. So as a decimal, 1.75. As a percent, 175%. Now, again, at this point, if you're feeling like this makes perfect sense to me, I'm ready to go do my checkpoints in my note-taking guide, you go right ahead. I'm going to go through a couple more examples for those who would like additional practice. In fact, it might be a good idea to try one on your own and then see what I get. Let's go through number 9. 7/8 means 7 divided by 8. Using traditional long division, I can add a decimal point and a 0, put my decimal point up into the quotient, and think about how close can I get to 70 using 8. Let's see. 8 times 8 is 64. 8 times 9 is 72. So it looks like 8's the closest I can get. 8 times 8 is 64 with a remainder of 6. I'm not quite done yet, so I'm going to go ahead and add another 0, bring it down. 8 times 7 is 56. That's going to give me a remainder of 4. 60 minus 56. I'm going to keep going. I'm going to add another 0, bring it down. Well, I know 8 times 5 is 40, so I'm finished with my division. So the decimal form of 7/8 is 875 thousandths. Changing that into its percent form, I'm getting 87.5%. So there's an example of taking a fraction and writing it in its decimal and then its percent. Let's take a look at 5/12. Another good thing to do is to estimate before you start dividing. Look at 5/12. That's a fraction that's close to a half. So I should end up with a percent that's pretty close to 50%. But all right, I'm going to go ahead and divide. 5/12 is 5 divided by 12. This time I'm going to use partial quotients. Since I'm going for a percent, I'm going to just add 2 zeros to get to the hundredths place. And I'm going to treat it like 500 divided by 12. And keep in mind, my answer should be close to 50%, but less when I'm finished. I'll come back to that later. All right, let's see. Well, I know 12 times 4 is 48. So 12 times 40 would give me 480. That'll give me a remainder of 20. 12 can go into 20 one more time. 1 times 12 is 12. When I subtract, I'm going to get a remainder of 8. Now that 8 is less than 12, so I can stop dividing. I got 41 and 8/12 for my answer. If I simplify that by dividing both of these numbers by 4, I'm getting 41 and 2/3, which is pretty darn close to 42. And that's close enough. Now going back to, I'm looking for a decimal that's close to 1/2 and a percent that's close to 50%. So it looks like the answer to 500 divided by 12 would be close to 42. The answer to 5.00 divided by 12 is going to be 42 hundredths approximately, since I rounded. So we're looking at approximately 42%. Again, that was close to 50%, but lower. Let's take a look at number 11, 11/6. I think this time I'll use traditional long division. 11/6 is 11 divided by 6. And I know 6 can go into 11 once. 1 times 6 is 6. Remainder 5. Well, that's not done yet, so I'm going to add a 0 here and a decimal point. Put my decimal point up in my quotient, bring down the 0, and let's see how close we can get to 50. 6 times 8 is 48. Going to get a remainder of 2. Not quite done yet. Add another 0, bring it down. 6 times 3 is 18. It's going to give me a remainder of 2. So what's going to happen is I'm going to keep going. If I keep going, I'm going to keep adding zeros, and I'm going to keep getting this. 6 goes into 23 times. So the decimal form of 11/6 is 1.83 repeating. So it'd be probably easier at first to write it as 1.8333 and so on. Making that into its percent form means moving the decimal point to the right twice, which is going to give me 183.3 repeating percent. There it is. One last one to go. I'm looking at 5/4, and I certainly could do a division here. But that denominator of 4, if I'm working with a percent is always out of 100. So this would be much easier to just put into its percent form this way. 4 times 25 is 100. 5 times 25 is 125. 125 divided by 100, or over 100, is equal to 125%. I'd get the same answer if I did a long division, but to me this is much simpler and more efficient when you've got a nice denominator like 4. That would also work if you had a 2 for a denominator, or 5, 5, or any number that's a factor of 100. So I'm going to go with that. All right. Now you're ready to do your checkpoints at this point. So I'm going to have you try checkpoints 9 through 12 in your note-taking guide on your own. We're going to evaluate and discuss those in class.